In the beginning of our understanding of the cosmos, gravity was invisible, not because it was weak or subtle, but because humanity had no name for what it could not see. People watched apples fall. They watched the moon glide across the night sky. They felt the pull of the earth, holding their feet to the ground. Yet for thousands of years, no one realized that every one of these moments was connected by the same universal principle. Gravity was everywhere, shaping everything, and no one knew it. Imagine an autumn afternoon in the late 1600s. Isaac Newton sits alone near an orchard, not far from his family home in Woolsthorpe. He is young, thoughtful, and as curious about the world as a child pressing a face to a window. A fallen apple is not special, it is ordinary. Yet Newton sees something no one else has seen before. Why does the apple always fall downward? Why not sideways or upward? Why does it obey this direction so consistently? Something in that question opens a crack in the wall separating superstition from science. Until Newton, motion was explained by stories. Fire wanted to rise toward the gods. Earth wanted to sink back into the soil. The moon circled overhead because it was somehow perfect and forever. But Newton looked deeper. He imagined the apple and the moon as equals. Perhaps the apple falls because the earth pulls it. And if the earth pulls the apple, then does it not also pull the moon? If so, could the moon be falling forever, always missing the earth because it moves sideways at just the right speed? That was the radical leap. The same force that makes an apple drop could hold a moon in orbit. This idea collapsed the wall between earth and sky. For the first time in human history, the universe was not divided into the mundane and the divine. Newton revealed that there was only one reality, unified by a force reaching across unthinkable distances. He gave that force a name: gravity. He then wrote a mathematical law bold enough to challenge every myth and every ancient explanation. Gravity is universal. Everything pulls on everything else. The strength of that pull depends on the mass of the objects and the square of the distance between them. At first glance, the law appears simple, yet its consequences are monumental. This one principle explained the dance of planets, the precession of comets, the tides of the oceans, and the fall of every grain of sand. Consider what this means. Every star in the night sky feels your presence. Every molecule of water in the ocean feels the pull of distant galaxies. The force is weak at small scales, but it is universal. Mass speaks the language of gravity, and nothing is silent. If gravity were suddenly gone, everything would scatter. The Earth would stop tracing its steady path around the Sun. Freed from orbit, it would drift into the cold emptiness of space. The Moon would lose its balance and drift away. Tides would vanish. Seasons would collapse. The entire system that shelters life would unravel. Without gravity, there would be no planets, no stars, and not even atoms long enough to build the smallest molecules. Structure itself requires gravity. It is the quiet architect of reality. Newton knew that gravity was instant and absolute. His mathematics worked. Observations matched predictions. Yet there was an unsettling question hidden underneath. How could the Earth pull on the Moon across a void with nothing in between? What carried that force? Newton had unified the heavens and the earth, but he had not explained the mechanism. He admitted openly that he did not know how gravity acted across empty space. He once wrote that it was ignorance to pretend to know how one body could influence another without something that connects them. He left that mystery to the future. For more than 2 centuries, his law guided ship captains, mapped the motion of planets, and carried spacecraft into orbit. Newton gave humanity the mathematical bones of gravity, but he knew there was deeper truth buried underneath. In our time, it is tempting to take this insight for granted. To us, gravity is familiar. We experience it every moment. We rarely question it. We rarely notice it. Yet what Newton discovered was a key that unlocked the universe. Before him, the sky was a realm apart, unreachable and unknowable. After him, it became a place governed by reason. The apple was never about the fruit. It was about the realization that the universe is intelligible, that we are not powerless observers, doomed to admire the stars without ever understanding them. Newton took us from spectators to participants. The theory worked so well that it became the foundation of modern civilization. Every bridge, every skyscraper, every rocket, every satellite orbit that brings us global communication all rely on Newton's equations. Gravity became predictable, calculable, a law that could be written with chalk on a board and tested in the real world. Humanity had turned a mystery into a tool. But beneath the triumph, a question remained unspoken. Newton's gravity acts instantly across distance. If the sun disappeared in a moment of impossible imagination, Newton's law says the Earth would feel the loss of its pull immediately. Yet nothing else in the universe behaves instantaneously. No signal, no information, not even light can move faster than light itself. Something about gravity did not quite fit. 200 years later, a young patent clerk who walked home every night staring at the street lamps would return to this puzzle. In doing so, he would tilt the entire universe and introduce a stranger truth. Gravity was not a force at all. It was something deeper, something woven into the shape of reality. Gravity was powerful, but it was still unexplained. Newton gave us the rule, but not the reason. The universe obeyed his equations with astonishing precision, yet the heart of the mystery still pulsed unanswered. How does one object influence another across space when nothing connects them? Why should mass bend the path of another mass? Newton refused to invent an explanation. He simply described what nature does and trusted that another mind, centuries later, might see further. Time passed. Science advanced. Humanity built observatories that pierced deeper into the night sky. We mapped planets, discovered new worlds farther from the sun, measured their orbits, and predicted their future positions with astonishing accuracy. Every measurement affirmed Newton's law. But success has a strange effect. When an idea works too well, we stop questioning it. We forget that even the most powerful explanation can still be incomplete. Then came the early 1900s. A young man named Albert Einstein worked as a clerk in a patent office. He spent his days sorting other people's inventions and his nights thinking about the nature of light, motion, and time. Where others saw routine, he saw possibility. He walked home beneath lamplight, not noticing the world around him, lost in equations that lived only in his mind. He read Newton's law. He admired it. But something bothered him. The instant pull of gravity violated a deeper rule of the universe, a rule Einstein believed was absolute. Nothing can influence anything else faster than light. This meant something extraordinary. If Newton's gravity acted instantly, then Newton's picture of the universe could not be entirely correct. Einstein did not start with gravity. He started with light. He asked what happens when you chase a beam of light at the speed of light. The question caused a revolution. He discovered that time is not fixed. Time can stretch or shrink, space can warp or twist, and the faster you move, the more reality bends around you. But light was only the beginning. He then asked another question, a simple one. What does gravity feel like from the inside? Imagine riding in an elevator. If the cable snaps and you fall freely, you feel weightless. Not lighter, weightless. The floor no longer presses upward on your feet. Gravity has not disappeared. You are still falling toward the earth. But because the elevator falls with you, the force becomes invisible. Einstein realized that falling freely through space is indistinguishable from floating in the absence of gravity. He called this the equivalence principle. This idea led to the most profound insight in the history of physics. Gravity is not a force, it is the shape of space and time. Mass tells space how to curve. Curved space tells matter how to move. Planets do not orbit because the sun pulls them. They orbit because the space around the sun is curved, and motion naturally flows along that curvature like a marble rolling along the surface of a stretched sheet. The sun is not reaching out with invisible hands. It simply bends the fabric of reality, and the Earth follows the path of least resistance. Einstein showed that space is not an empty stage. It is dynamic, living, responsive. Every star, every planet, every breath of matter reshapes that cosmic fabric. Imagine a bowling ball placed on a trampoline. The surface curves around it. Now place a marble near the ball and give it a gentle push. It circles and spirals inward, not because the ball pulls it, but because the surface beneath it guides its path. The marble obeys geometry, not force. Reality works the same way. Only instead of a two-dimensional sheet of fabric, the universe bends in 4 dimensions, 3 of space, 1 of time. When Newton saw gravity as a mysterious attraction, Einstein saw a universe of geometry. Space is not flat. Time is not absolute. Gravity is the curvature of existence. This was not philosophy. It was measurable. In 1919, astronomers observed starlight bending as it passed near the sun. The amount of bending matched Einstein's prediction perfectly. Gravity was not pulling the light. Space itself was curved, and the light simply moved along the only path available. The cosmos had revealed its structure. Yet even Einstein could not foresee what this idea would unleash. He opened the door to black holes, where gravity is so intense that space folds inward. He opened the path to understanding how stars live and die. He laid the foundation for modern cosmology, the study of the universe as a whole. Newton gave us the rules of the cosmic dance. Einstein revealed the flaw beneath the dancers. Gravity was no longer a force. It was a consequence, a relationship between mass and the shape of reality. And yet, for everything Einstein explained, the universe still held secrets. His equations showed that space should be dynamic, either expanding or contracting, but the sky seemed still. Einstein added a correction to keep the universe static, a choice he later called his greatest mistake. Because when astronomers looked deeper, they found that space is stretching, the universe is expanding, galaxies are racing away from one another, not because something pushes them, but because the fabric of space itself grows. Gravity is not only the architect of motion, it is the sculptor of time. In the coming chapters, we will follow gravity from its quiet influence in the birth of stars to its relentless pull inside black holes. We will watch it compete with something even stranger, a repulsive pressure that stretches the universe faster over time, a pressure we call dark energy. But before we go that far, stand for a moment at the edge of Newton's orchard and Einstein's curved space-time. The apple falls, the moon moves, the universe curves. Gravity does not pull, it shapes. And because of that shaping, reality holds together. For most of human history, we believed gravity was a force. We imagined it pulling downward like a hand, dragging objects toward the earth. Newton's brilliance made this picture feel complete. He gave us equations that allowed sailors to cross oceans, observatories to predict eclipses, and eventually allowed spacecraft to reach orbit and beyond. Yet there was still an unanswered question hidden inside the theory that nobody could ignore forever. How could something act across empty space without touching what it moved? Einstein did not reject Newton. He honored him. Newton revealed how gravity behaves. Einstein wanted to know why. To understand what Einstein saw, imagine floating alone in deep space. No sound, no air, no sensation of weight. Instead of falling downward, you simply move in whatever direction your last push sent you. No friction slows you. No wind resists you. If you release a wrench from your hand, it floats beside you. Both you and the wrench drift along parallel paths, motion without effort. Now imagine that space around you is not perfectly flat, but slightly curved, like a gentle slope. You do not feel any push, but your path bends. The wrench follows the same curve. Neither of you is being pulled. You are simply following the natural shape of space. That is gravity. Einstein understood that mass and energy do not sit silently in the universe. They tell the very shape of space how to bend. Then space tells matter how to move. The Earth does not chase the sun. The sun shapes space, and the Earth follows the path carved beneath it. This perspective changes everything. It means that gravity is not a command issued from afar. It is the architecture of reality. When a planet orbits, it is not resisting a pull. It is simply moving along the straightest possible line inside a curved environment. In mathematics, that path is called a geodesic. The shortest path between 2 points is not always what appears straight to our eyes. When space curves, straightness curves with it. If you were standing on the surface of a sphere and walked forward, never turning your legs right or left, you would eventually return to your starting point. You would have walked straight the entire time, yet your path would be curved. Einstein realized that the universe behaves this way. Put mass in space, and straight paths around it become curved. Motion adapts. This is why planets orbit without needing a continual push. They are falling, not downward, but forward along the curved geometry of space. They never stop falling, and therefore never hit what they orbit. The Earth is in continuous free fall around the Sun. The Moon is in continuous free fall around the Earth. You are also in free fall at this moment, held upright only because the ground pushes against your feet. You feel weight because you are prevented from following the path space wants you to take. Weight is not something gravity gives you. Weight is resistance to falling. Einstein proved this with the elevator thought experiment. Imagine being inside a sealed elevator in deep space. If rockets underneath accelerate upward, you feel pressed to the floor. If the cable snaps while the elevator hangs on Earth, you feel weightless. In both cases, the sensation arises not from the presence or absence of gravity, but from whether you are allowed to follow the natural curve of space-time. This realization leads to one of the most astonishing truths ever discovered. Gravity is not a force, but an illusion created by geometry. The universe does not pull, it guides. Einstein's idea went beyond philosophy. It predicted phenomena nobody had ever imagined. If space can curve, it can curve strongly. Enough mass compresses space into something deeper, something from which not even light can escape, a place where geometry folds inward until motion becomes impossible. This theoretical prediction was so strange that even Einstein doubted that nature would allow such an extreme object. We now know it does. Black holes are not holes at all. They are regions where the curvature of space-time becomes absolute. Einstein also realized that if mass can bend space, then moving mass can create ripples through space, like a pebble tossed into a pond. When two massive stars spiral together, they disturb the fabric of reality itself. Those ripples travel at the speed of light. For 1 century, those waves remained a prediction. Then, in the year 2015, scientists at the Laser Interferometer Gravitational Wave Observatory detected the first gravitational wave ever recorded. 2 black holes had collided more than 1 billion light-years away. Their violent embrace shook space-time, and the ripple eventually reached Earth. Humanity felt the universe vibrate. Newton united the heavens and the earth. Einstein united space and time. Everything you see, everything you touch, Everything that exists is built upon that deeper structure. The universe had revealed its geometry, but a deeper revelation waited in the shadows. When Einstein finished describing how mass shapes space-time, he returned to his equations and noticed something strange. They allowed the universe to move. Space could stretch. Time could evolve. If space-time was dynamic, then the universe itself could grow or shrink. Yet everyone at that time believed the universe was eternal and fixed. To match that belief, Einstein added a term that forced his equations to keep the universe still. Years later, he called it his greatest mistake. The universe was not holding still. It was expanding. A young astronomer named Edwin Hubble looked through a powerful telescope and saw galaxies far beyond the Milky Way. Some drifted away slowly, others raced faster. All moved outward. Space was stretching, pulling galaxies apart, not because something pushed them, but because the fabric between them grew. Einstein removed his correction. The universe did not need help to evolve. It was doing so naturally. With this understanding, gravity became more than geometry. It became the history of everything that has ever existed. Stars ignite because gravity squeezes clouds of gas until fusion begins. Galaxies form because gravity draws countless stars into spiraling congregations. Even the large-scale structure of the universe, the immense interconnected web of galaxies and matter exists because gravity shapes it over billions of years. We are not passive observers living in a distant corner of a random cosmos. We are participants in a process that has been sculpting itself since the first moments of time. Imagine watching the universe in reverse. Galaxies drift inward instead of outward. Clusters tighten. Stars move closer. Everything compresses. At some distant moment in the past, all matter and energy existed in a state of unimaginable density. Time and space emerged not from a location, but from a beginning. Gravity helped shape those earliest instants, guiding matter as it expanded and cooled, allowing stars and planets to rise from the cosmic fog. Gravity does not simply hold things together, it decides what can exist at all. Even now, it continues its quiet work. In the center of our own galaxy, a supermassive black hole bends space-time into an invisible funnel. Stars close to the center move at immense speed, their orbits warped into tight curves by the immense mass buried in the darkness. We cannot see the black hole itself. We observe its influence. We watch stars complete long, elegant circuits around a point that radiates nothing. Geometry reveals what our eyes cannot. Einstein used thought to reach truths that could not yet be tested. Today, we test them constantly. We send satellites equipped with atomic clocks to measure how time runs slower when closer to mass. We observe starlight bending. We detect gravitational waves. We saw the shadow of a black hole when the Event Horizon Telescope combined radio observatories across the planet Earth into a single planet-sized instrument. Everything agrees with Einstein's idea. Space curves, time bends. Gravity is not a force, yet for all this power, gravity is also fragile. It is the weakest of the fundamental interactions. A refrigerator magnet that fits in your palm can lift a nail against the entire pull of the planet Earth. Yet gravity dominates the cosmos because everything that has mass participates in it. Unlike electric charge, which can cancel itself out when positive and negative charges mix, gravity always adds. All mass pulls, all mass shapes space-time. This is why gravity rules on large scales, not because it is strong, but because nothing opposes it. Consider how remarkable this is. The force that keeps your feet on the ground is the same one that commands the motion of galaxies. The same principle that guides a falling raindrop determines the orbit of planets, the fusion of stars, and the shape of time itself. If we could step outside the universe and look at it as a whole, we would see filaments of matter stretching across unimaginable distances. They resemble veins or rivers, channeling galaxies along vast cosmic highways. At the intersections of those filaments lie clusters containing hundreds or thousands of galaxies. Gravity sculpts these structures like a sculptor shaping clay. Given enough time, tiny variations in density grow. Matter falls toward matter. Patterns emerge from chaos. The universe organizes itself. All of this flows from Einstein redefining one concept. The world is not held together by pulling forces reaching across space. It is held together by the shape of space itself. Your life unfolds inside that curvature. The passing of every second depends on where you stand in that landscape. Time on the surface of the planet Earth is slightly slower than time on a satellite in orbit. We only notice this difference because our technology demands precision. The Global Positioning System uses satellites equipped with clocks so accurate that even a tiny change matters. Engineers must account for general relativity. If they did not, navigation errors would build until the system became useless. Every time a map directs you through a city, you are using Einstein. His theory does not live only in blackboards and textbooks. It lives in every moment of modern civilization. And despite all of this, most of the universe remains unknown. Gravity is the storyteller of cosmic history, but it whispers secrets we have not yet learned to translate. Galaxies spin far faster than visible mass can explain. Gravity tells us there is more matter out there than we can see. An invisible substance surrounds galaxies and holds them together. We call it dark matter. Far beyond that mystery lies another. The expansion of the universe is speeding up. Something pushes space-time outward. We call this dark energy. Einstein opened the door. The universe stepped through it and revealed that there are still deeper mysteries waiting in the dark. Gravity guided our first questions. Geometry guided our greatest revelations. Now new questions wait in the unexplored night. In the next chapter, we will follow gravity not across empty space, but inward to its most intimate battle. The struggle between collapse and fire, the birth of stars. In the darkness between stars, space is not empty. It holds vast clouds of gas and dust, thin as breath and spread across light years of distance. At first sight, they seem silent, motionless, harmless. Yet inside these clouds, a battle begins. Gravity tries to pull every particle inward. The atoms resist, moving and colliding, creating pressure from their motion. This tension between collapse and resistance is the beginning of every star. Picture a cloud of hydrogen drifting in a quiet corner of a galaxy. Hydrogen is the simplest atom, one proton, one electron. It is the building block of everything that burns in the sky. For millions of years, the cloud floats, changing shape under gentle currents of gravity from the surrounding galaxy. At first, nothing dramatic happens, but gravity never sleeps. Its pull is patient, steady, relentless. Given enough time, even the weakest attraction becomes dominant. The cloud begins to contract, slowly at first, then faster. As particles move inward, they accelerate. Collisions become more frequent. As particles collide, they heat. Motion turns into warmth. Warmth becomes fire. Gravity does not simply pull matter together. It converts potential energy into heat. At the center of the shrinking cloud, a core forms. It grows hotter and denser with every passing moment. In that rising temperature lies destiny. If the core becomes hot enough, the atoms will begin to fuse. Fusion is the most powerful source of energy the universe has ever known. When two atomic nuclei join, they release pure energy. The reaction follows Einstein's equation that says mass and energy are the same thing. A tiny loss of mass becomes a flood of light and heat. But before fusion can begin, the core must reach a temperature of many millions of degrees Celsius. That threshold does not arrive gently. Gravity must squeeze the core with immense pressure. Every layer of gas above presses downward. The deeper the core sinks under its own weight, the faster the temperature rises. The cloud shrinks, the core brightens. And when the temperature finally becomes high enough, the universe changes. Fusion begins. Hydrogen atoms smash together so fiercely that they merge into helium. In that moment, the star is born. Light that was once trapped inside the shrinking cloud now bursts outward. Radiation escapes. A new sun ignites. But the birth of a star is not the end of the battle. Fusion pushes outward. Gravity pulls inward. A balance forms. Outward pressure from the fusion prevents total collapse. Inward pressure from gravity prevents the star from tearing itself apart. The two forces lock together in constant tension. The star is not passive. It breathes through fusion. It presses against gravity with every second that passes. If fusion weakens, gravity begins to win. If fusion grows too strong, the star expands until gravity regains control. This balance creates stability. A star can maintain this equilibrium for billions of years. Our own sun is the perfect example of this harmony. Every second it converts millions of tons of hydrogen into helium. The energy released radiates outward through layers of plasma before reaching the surface. From there it crosses space, taking a little more than 8 minutes to reach Earth. That light warms oceans, feeds forests through photosynthesis, and drives the climate that sustains life. The warmth that reaches your skin on a calm afternoon began inside the core of a star where gravity first forged fire. Yet even in that stability, a star is a temporary victory against collapse. Gravity waits. Fusion cannot last forever. Hydrogen runs low. The balance shifts. The star changes. But that story belongs to later chapters. What matters here is the realization that gravity shapes not only the motion of planets, but the very engines of creation. Without gravity, clouds of gas would drift forever. They would never compress enough to ignite. There would be no stars. Without stars, there would be no heavier elements like carbon and oxygen. Worlds would never form. Life would have no chemistry to stand upon. All structure begins with gravity challenging chaos. Consider again that contracting cloud of hydrogen. Before fusion begins, the core is dark. No visible light escapes. Astronomers call these young stars protostars. They glow only in infrared radiation, heat escaping as they contract. A cocoon of gas surrounds them. Eventually the cocoon thins. The new star emerges, shedding the last remnants of its birthplace. The surrounding gas may flatten into a spinning disk. That disk will become a nursery for planets. In this single system we see the entire chain of cosmic creation. Gravity forms the star. Radiation escapes. A disk surrounds it. Worlds coalesce and orbit. Stars are born not as perfect spheres of fire, but as monuments to gravitational patience. From afar, a newborn star looks serene, but inside, the forces are violent. At the smallest scales, atoms race and smash together, releasing energy at unimaginable densities. At the largest scales, gravity extends across billions of kilometers of space, shaping the path of every particle. The balance between these two extremes creates the star we see in the sky. Gravity forges the furnace. Fusion fuels the light. This balance explains why stars live long. Fusion does not explode all the hydrogen at once. Gravity squeezes slowly. Fusion burns slowly. The result is a steady stream of energy released over billions of years. A star is a controlled burn governed by geometry and physics. In this balance lies a deep truth about the universe. Creation is not separate from destruction. Fusion exists only because gravity tries to crush the star. Every sunrise on Earth is the visible result of a cosmic struggle being fought in the core of our sun. The universe does not waste anything. Even collapse becomes creation. The star continues its long equilibrium, but the universe evolves around it. The gas and dust that were not swallowed by the star begin to flatten into a wide rotating disk. Motion shapes matter. As the disk turns, particles collide and stick, forming clumps. The clumps become larger objects, each one attracting more material with its growing mass. Gravity begins again at a smaller scale. Tiny fragments merge into stones. Stones merge into giant mountain-sized bodies. These bodies sweep through the disk like predators, clearing paths and gathering anything that crosses their orbit. Time in this environment does not flow the way we feel it on Earth. Millions of years pass quietly. Collisions that appear violent in the imagination are slow on cosmic scales. Matter gathers. Orbits stabilize. The disk becomes organized. Gravity sculpts not only the star, but the space around it. The star continues to burn at its core. Fusion converts hydrogen into helium. Light escapes, traveling across space. Near the center of the system, the temperature is fierce. Volatile materials evaporate. Only rock and metal remain. Farther out, the gas is colder and lighter elements can survive. These outer regions form giant planets of hydrogen and helium. In this way, entire solar systems take shape. Every world that might one day hold oceans or atmospheres or life begins as dust drifting around a newborn star. And all of it depends on gravity pushing inward until fusion pushes outward. The star itself remains stable, but deep inside a story unfolds that will not end until the hydrogen grows scarce. Fusion is a negotiation. Hydrogen fuses into helium, but helium does not burn as easily. Eventually, the star will exhaust the fuel in its core. When that day arrives, gravity will tighten its grip. The core will shrink. Pressure will rise. The outer layers will expand. The star will swell and glow red. The peaceful equilibrium will end. But that destiny lies far ahead. For now, the star maintains its balance. Fusion pushes outward with precision. Gravity presses inward with equal strength. This harmony is called hydrostatic equilibrium. Hydro means fluid. Static means stable. The star is a stable fluid, a sphere of plasma held in perfect tension. Inside this balance, every photon of sunlight that reaches Earth begins as a struggle in the star. A single photon may spend thousands of years bouncing inside the star before it escapes into space. Once free, it crosses the void with nothing to slow it. When it reaches our world, it nurtures every leaf and warms every sea. Plants convert sunlight into stored energy. Animals consume plants and carry that energy further. Life on Earth is a chain of captured starlight. When you feel the warmth of the sun on your face, you are feeling the victory of fusion over collapse. Yet the star is not aware of the life it supports. It burns because physics demands it. Gravity closes the hand. Fusion opens it. This balance persists because it cannot be otherwise. The universe is not careless. It is governed by laws that remain the same everywhere across space and time. If we could watch the star from an impossible position outside of time, we would see a rhythm. The core burns steadily. The outer layers churn with convection, rising and falling like slow-moving tides of plasma. Magnetic fields twist and unwind. Sunspots appear where magnetism holds back heat. Solar flares erupt when magnetic tension snaps. The star breathes energy into space. Even in its quiet moments, the star influences everything around it. Solar wind flows outward from its poles. This stream of charged particles interacts with the magnetic field of any nearby planet. On Earth, it creates auroras that shimmer in polar skies. The dancing lights remind us that we are connected directly to the star. Every world in its orbit depends on this light. Too close and the heat burns away any chance of oceans. Too far and water freezes into eternal ice. A narrow band exists where liquid water can survive. Scientists call it the habitable zone. Earth lives in that band. That balance between heat and distance exists only because gravity set the position of the planets. When we look up at the night sky, we are not seeing stars. We are seeing furnaces where gravity and fusion meet. We are looking at distant battles that have already been won. Yet even these stars are temporary. Fusion cannot last forever. As hydrogen becomes scarce, the core contracts. The outward pressure weakens. Gravity begins to dominate. The star changes shape. Its outer layers swell. Its color shifts. It becomes a red giant. Eventually, those outer layers drift away into space, leaving behind the dense core. The core becomes a white dwarf. Gravity holds the dwarf together. It no longer burns fuel. It only cools across countless billions of years. This fate awaits stars like our Sun. But stars much larger live shorter and far more dramatic lives. When massive stars run out of fuel, their cores collapse in an instant. Gravity wins completely. The sudden collapse causes the outer layers to explode outward in a titanic explosion called a supernova. In that moment, the universe creates elements heavier than iron: gold, silver, uranium, the matter that becomes planets and the matter that becomes us. Every atom in our bodies was forged in the heart of a star or in the violence of a supernova. So the story that began in a dark cloud of hydrogen ends in the creation of the very atoms that form our bones and our breath. Gravity does not simply build stars, it plants the seeds of future worlds and future life. We like to believe that we are separate from the stars, that the sky is above and we are below. But every part of us was once stardust held inside a cloud, waiting for gravity to begin the next chapter. When we stare at the night sky, we are not looking at distant strangers. We are looking at our origin. Gravity guides the cloud. Fusion ignites the fire. Stars forge the elements. Planets form around them. Life emerges from the remnants. The universe is not random. It is a sequence, a story written in light. In the wake of a star's birth, the space around it changes. What was once a chaotic disk of gas and dust begins to settle. Patterns form. Order emerges. Gravity does not shout or force. It whispers, it nudges, it guides. And those faint nudges slowly sculpt motion into structure. The disk around a young star spins because the cloud that formed it once rotated. Even a gentle rotation becomes important when spread across millions of kilometers. Gravity pulls inward. Motion keeps the material from falling straight into the star. These two influences, inward pull and sideways motion, weave a balance that no one directly sees, but every world follows. Pieces of dust collide and merge. The motion spreads them into rings. Within each ring, gravity draws clumps together. Over time, these clumps become massive enough to influence their neighbors. The more mass they gather, the stronger their pull becomes. The space around each clump clears. Smaller fragments either merge or are flung away into distant regions of the system. What remains are young worlds in the making. Everything in this forming system participates in a quiet negotiation. The star pulls inward. The planets pull on one another. Each orbit adjusts until harmony emerges. When the balance settles, a planetary system is born. Imagine standing far above, watching from a perspective no living thing has ever occupied. The star glows at the center, steady and patient. Around it, planets trace paths like brushstrokes on a vast black canvas. They do not move in circles by accident. They follow the straightest possible lines through curved space-time. Each world travels forward continuously, trying to go straight. Gravity simply bends the space beneath them, guiding their path into an endless fall around the star. A planet in orbit is in free fall. It is always falling toward the star, yet it never arrives. Its sideways motion forever misses the surface. That constant forward movement is called angular momentum. Without it, the planet would plunge inward. With too much of it, the planet would escape entirely and disappear into the cold of the galaxy. Angular momentum is not something planets choose. It is inherited. The young planet keeps the motion of the cloud that formed it. The spinning disk becomes spinning worlds. We think of orbits as flawless loops, but they are not rigid or absolute. Gravity permits tiny changes. A distant passing star might stretch the orbit slightly. A massive planet might tug a smaller one into a new path. Even the planets tug on the star, causing it to wobble ever so slightly. That wobble reveals the presence of planets to astronomers across unimaginable distances. The space between worlds contains more than emptiness. There are places called gravitational balance points. If a smaller object settles there, the combined gravities of the planet and the star cancel in just the right way. These regions act like invisible harbors. Material can remain there for millions of years. Spacecraft can rest there with minimal effort. These points reveal the hidden architecture of the system. Gravity does not only create motion, it creates equilibrium. In our own system, there are several of these balance points around Earth. Some hold dust, others hold space observatories that study the universe without the interference of Earth's atmosphere. Those observatories rely on mathematics that began with Newton and deepened with Einstein. Their position remains stable because gravity and motion form a perfect conversation. Every world in a planetary system is a participant in that quiet conversation. Each orbit represents a unique agreement between gravity and motion. Planets do not fight the pull of the star. They flow with it. They surrender to the curve of space-time. The space between orbits may appear empty, but this emptiness is full of meaning. It holds the memory of collisions that failed. It holds the pathways cleared by planets that succeeded. It even holds the potential for new worlds that may form in distant futures. Planets keep their orbits not because they resist gravity, but because they cooperate with it. They move forward while falling inward. Motion and gravity are equal partners. Without motion, gravity collapses everything into the center. Without gravity, motion flings everything outward into the dark. The sky above us is not chaos, it is choreography. If we could hear the motion of planets the way we hear music, each orbit would be a note. Each period of rotation would be a rhythm. Together, they form a kind of celestial harmony, an order so precise that ancient civilizations tried to measure it with tools carved in stone, believing the heavens were divine. They were not wrong to think the cosmos speaks in patterns. They only lacked the language to describe it. Today, we have that language: orbit, angular momentum, gravitational equilibrium. These words are the grammar of celestial architecture. Even though planets and stars follow predictable paths, the universe is never frozen. Gravity continues shaping every orbit. The paths shift slowly as billions of years pass. Moons migrate outward. Planets exchange momentum through subtle interactions. Nothing remains still. Gravity teaches that motion is not disorder. Motion is the way the universe expresses stability. From the tiny dust of a forming disk to the majestic sweep of planets, all motion is guided by the same principle. To orbit is to fall forever. The planets circle without effort, yet every moment of their motion is a triumph of balance. If the star were lighter, their orbits would drift farther outward. If it were heavier, the same orbits would tighten. Change the mass of a planet and the harmony shifts. The system is like a symphony where each instrument plays a single constant tone. If one instrument grows louder or softer, the others adjust. Nothing remains entirely independent. We often imagine gravity as downward because we live upon a surface that stops our fall. But in space, there is no down. There is only motion and curve. A planet does not know that it moves around a star. It only knows that it follows the straightest possible path. The star does not know that it holds the planets. It merely shapes the space around it. The orbit is the outcome of both. We speak of orbits as though they are permanent, but permanence is an illusion. Over immense stretches of time, worlds migrate. Gas giants can drift inward toward the star, or outward toward the dark. In some systems, giant planets wander so close to their star that their atmospheres are stripped away. In others, they travel so far from the star that they freeze into silence. Gravity sets no preference. It merely responds to the motion that matter carries. In our own system, the distance between planets is not random. Scientists have discovered subtle patterns. The planets occupy regions where gravity and angular momentum settle into long-lasting arrangements. It is as if gravity offers certain seats at its table, and planets occupy those seats when the conditions are right. Anything that fails to find balance is swept aside or sent drifting into the void. Some systems contain planets locked into a shared rhythm. One planet might orbit twice in the same time that another completes a single orbit. They never collide. They never drift apart. They move as if bound by invisible choreography. This is called resonance. The planets do not communicate. Gravity communicates for them. Sometimes the balance becomes fragile. If two planets pass too close to each other, even once in millions of years, their orbits can change. One may be sent farther out. The other may be nudged inward. These alterations can scatter smaller objects or send them inward toward the star. The stability we observe today is not guaranteed. It is earned through time. Far beyond the giant planets of our system lies a realm of ice and rock. Shattered remnants of formation orbit in a slow, cold ballet. Some of those fragments fall inward on long-stretched paths. When they approach the star, heat awakens the ice, and dust streams behind them like a tail. We call them comets. They are travelers of deep time carrying memories of the system's birth. Each one is a messenger from the edge. When a comet passes near a planet, a subtle game unfolds. Gravity changes the comet's path. The comet also tugs the planet by an imperceptible amount. Even the smallest interactions matter. Gravity notices everything. Every moon, every asteroid, every grain of dust that orbits anything does so for the same reason. Forward motion and inward curvature agree on a path. There is no need for control or command. The universe does not need supervision. It follows laws that require no correction. Consider a spacecraft leaving Earth. To leave the planet behind, it must move faster than the curvature of space can bend its path back. That speed is called escape velocity. For Earth, it is a little more than 11 kilometers per second. If the spacecraft reaches that speed, it no longer falls back. It moves into the larger curve of the Sun. To escape the Sun, the spacecraft must increase its speed again. All motion is a negotiation with gravity. Speed becomes freedom. Every spacecraft humanity has launched relies on the same geometry as planets. When a spacecraft flies past a planet, it can steal a little of the planet's motion, gaining speed without using fuel. This is called a gravity assist. Engineers understand that space is not emptiness, but a landscape that can be navigated. They learn to ride curvature the way sailors ride the wind. We think of planets as isolated bodies, each following its own orbit. But the truth is deeper. All orbits are connected. Every planet affects every other. The star guides. The planets respond. The system settles into harmony only when the sum of forces agrees. Orbits are silent conversations. A planet does not move because gravity forces it. It moves because gravity shapes the path beneath it. The planet follows the path that space offers. In this way, gravity and motion are partners. Neither dominates, both define. If we could stand at the edge of the system and watch the orbits unfold in accelerated time, we would see worlds shifting slightly, moons spiraling outward, comets diving inward, debris rings thickening and thinning. Nothing is fixed. Yet the system remains whole. Gravity creates order not by freezing motion, but by guiding it. The greatest revelation is that the planets are not held in place. They are freed. Free to move without friction. Free to fall forever. Free to follow the shape of reality. When we look into the night sky and see a single bright point, we assume it is still. But that point may be a world rushing around its sun with astounding speed. A world where seasons rise and fall. A world where gravity has sculpted an entire story. Orbits are not cages. They are freedom expressed as motion. Everything that moves in space moves because gravity makes room for the motion. The planets continue their long fall around the star. The star continues its distant fall around the center of the galaxy. And the galaxy drifts through the deep fabric of the universe, following curves we have not yet fully understood. The silent balance that guides worlds also guides us. Earth spins and moves along its orbit without a sound. We do not feel the motion. We feel only the ground beneath us. But every sunrise and every season are born from that motion. Gravity holds the shape of the year. The journey from the birth of a star to the harmony of orbits is not the end. The same balance that shapes solar systems also shapes something far larger. When billions of stars gather, the stage expands. Gravity takes on a grander scale. The next chapter will follow gravity into the vast, spiraling cities of stars called galaxies. A galaxy begins the same way a star does, with gravity. In the young universe, matter drifts through expanding space like fog across a field at dawn. At first, the fog is nearly uniform, but even the faintest unevenness matters. A region ever so slightly denser than its surroundings gains an advantage. More mass gathers there, more gravity forms. The gathering strengthens, the region grows heavier, denser, more attractive. The universe is patient, it gives gravity time. Over millions upon millions of years, those regions pull gas, dust, and dark matter inward. The dark matter forms a vast halo. This halo is invisible, yet it becomes the skeleton of the future galaxy. It shapes the space around it. Its pull gathers ordinary matter the way a riverbed gathers water. Gas collapses toward the center, not quietly, but by spiraling. Matter never falls straight inward. A touch of rotation always exists. When spread across cosmic distances, that tiny rotation becomes motion of astonishing scale. Instead of collapsing directly into a single point, the cloud flattens into a rotating disk. The process mirrors the birth of a star system, but multiplied by billions. Where stars form planets, galaxies form stars. Within that rotating body of gas, density increases. In scattered pockets, gravity wins again and again. New stars ignite like sparks along the rim of a cosmic wheel. They cluster, lighting the dark. The galaxy evolves into a glowing spiral, arms sweeping outward from the dense center. The spiral arms are not rigid, they are waves of density. As the stars and gas move through those regions, they slow slightly. This slowing causes more matter to collect there. The arms persist, not because they are solid structures, but because the wave continually concentrates fresh stars. A galaxy is not a thing, it is a process. The center grows more crowded. Billions of stars move around one common point. Gas flows inward and forms new stars. Heat from those newborn stars pushes outward and slows the collapse. The balance of falling and resisting repeats on a scale far beyond any solar system. Yet the heart of the galaxy does something even stranger. It forms a black hole, not a small one, not a collapsed star. This is a creature of unimaginable mass, a supermassive black hole. millions or sometimes even billions of times heavier than our Sun. Its gravity bends space-time so sharply that anything that passes too close cannot escape. Even light loses the battle. The black hole does not pull the stars around it. It simply shapes the space-time they move through. Stars near the center of the galaxy race along tight curves, moving at immense speeds. They do not collide. They follow geometry. The black hole is silent. It does not shine. Yet the motion of stars reveals its presence. It is the unseen anchor of the galactic city. The arms of the galaxy sweep outward. They hold clusters of stars in motion. Each cluster holds star systems. Each star system holds worlds. And each world holds chemical stories written by earlier generations of stars. The heavy elements that formed those worlds were made inside stars that lived and died long before these new systems existed. The galaxy recycles itself. When a massive star explodes, it releases elements forged in its core. Those elements drift into space and become the ingredients of new stars and new planets. Every breath we take began inside a star. The gas that forms new stars does not move freely. Gravity locks it into the galactic disk. The disk rotates. The center spins fastest. The outer regions move slower. The spiral arms appear because the inner parts of the disk catch up to the outer parts. The stars in the arms are young and bright. They burn blue and die quickly. The stars between the arms are older and more yellow. They have existed long enough to slide beyond the waves that formed them. A galaxy is both memory and promise. Imagine drifting above the plane of such a galaxy. The disk stretches like a silver coin tilted in the darkness. The arms glow like luminous brushstrokes. If you could watch it for billions of years, you would see the arms ripple, twist, fade, reform. You would see wave after wave of star formation sweep through the gas. You would see stars live and die. You would see slow collapse and sudden birth. Gravity holds each star in motion. Motion shapes the arms. The arms guide new stars. Gravity harvests the results. Nothing here is accidental. Galaxies merge. They collide in slow motion. Their stars rarely touch because the distances between them are so vast, yet their gravity intertwines. The shapes distort. The arms twist. After the chaos settles, a new galaxy forms. The central black holes merge as well, releasing ripples in space-time that travel outward across the universe. These waves cross millions of light years, passing through countless galaxies until they eventually wash across us. We tend to think of galaxies as isolated islands in empty space. They are not. They are connected by threads of invisible matter that stretch between them. These threads are the structure of the universe itself. They are made of dark matter, the unseen scaffold that holds galaxies in place. If we could remove all the stars, all the planets, all the gas, and leave only the dark matter, we would see the true skeleton of reality. Filaments stretching like rivers of gravity. Intersections where the rivers meet. At each intersection sits a galaxy, or several. The universe does not scatter its stars randomly. It arranges them along these threads. Gravity is not only the architect of planets and stars, it is the architect of galaxies. It builds structures so large that the human mind struggles to picture them. Each galaxy contains hundreds of billions of stars. Each star can hold planets. Each planet might hold oceans. Some of those oceans might hold life. Somewhere, perhaps, gravity shaped a world where someone looks up and wonders as we do. A planet is the product of a star. A star is the product of a galaxy. A galaxy is the product of gravity. The city of stars continues to spin. The arms continue to ripple. The black hole continues to shape space-time in silence. And gravity continues to write its story. Yet even within this vast pinwheel of stars, something does not behave as expected. If gravity comes only from the visible stars and gas, The outer regions of a galaxy should rotate more slowly than the inner regions. Just as the outer planets in a solar system move more slowly than the inner ones, the stars near the edge of a galaxy should drift in quiet, wide arcs. But when astronomers measured the speeds, they found something astonishing. The stars in the outer regions moved almost as fast as those near the center. According to Newton's law of motion and Einstein's geometry of space-time, that should not happen unless something else provides additional gravity. At first, it seemed impossible. The stars that we see are not enough. The gas we measure is not enough. The galaxies rotate too quickly to remain whole. They should tear themselves apart, yet they do not. They remain intact. Their arms remain graceful. Their centers remain bound. So what holds a galaxy together? Astronomers proposed a remarkable idea. Perhaps most of the mass of a galaxy is not visible. Perhaps the galaxy is wrapped in a halo of unseen matter that does not shine or reflect light. That unseen matter creates additional gravity. It shapes the rotation of the galaxy. It holds the stars in place. We cannot see it directly, but we can observe its influence. The stars glide as though held within a vast, invisible bowl. The bowl is made not of light, but of mass that refuses to reveal its nature. We now call this hidden mass dark matter. Dark matter does not burn. It does not collide the way ordinary matter does. It passes through everything silently. It moves according to gravity alone. It forms halos around galaxies. It stretches into filaments across the universe. It shows us a blueprint of cosmic architecture. Galaxies are built where dark matter gathers. They grow along the filaments. They cluster at the intersections. Without this invisible framework, galaxies could not exist in the shapes we observe. Dark matter is the silent majority of the universe. Ordinary matter, the atoms that form stars and planets and life, is only a small fraction. The rest is the unseen structure that gravity uses to shape the cosmos. It is as though reality saves most of its material in the shadows, revealing only a small portion through starlight. Even with all this mass and motion, galaxies live peaceful lives for long stretches of time. But the universe is not still. Space expands. Galaxies drift. Eventually, they encounter one another. When two galaxies approach, their halos of dark matter begin to merge long before their stars come close. Then the spiraling forms distort. The arms twist into long tendrils. Stars are flung outward or drawn inward. Gas clouds collide. New bursts of star formation ignite. What looks like violence is actually creation. When the chaos settles, a single larger galaxy remains. The stars remember nothing of the collision. They simply follow the new curvature of space-time. This merging is not rare, it is universal. Even our own Milky Way galaxy is moving toward the nearby Andromeda galaxy. The distance between them is so great that light takes more than 2 million years to cross it. Yet their mutual gravity is patient. In several billion years, the two galaxies will merge. The spiral forms will warp. The arms will stretch into majestic streams. Stars will pass by one another without collision, but their paths will change. In the end, a new galaxy will emerge from the union. If there were observers on distant worlds when that event begins, they would see the night sky transform. A faint blur would appear. It would grow year by year across generations until an entire galaxy filled the sky. What appears to us as frozen eternity is actually motion on a scale so immense that human lifetimes are too brief to notice. Within every galaxy, the story continues downward into smaller scales. Stars orbit, planets orbit, moons orbit. Gravity is fractal. The same principle repeats at every level. The same laws govern everything from a grain of dust circling a young star to a supercluster of galaxies drifting through cosmic filaments. This pattern reveals something profound. The universe is not ruled by chaos. It is guided by order that emerges naturally from simple principles. Wherever mass gathers, gravity shapes motion. Wherever motion and gravity reach a balance, structure forms. Solar systems are not accidents. Galaxies are not accidents. They are consequences. The city of stars does not grip its inhabitants. It releases them to move freely within its shape. This freedom of motion is what keeps the structure stable. The stars do not resist gravity. They surrender to the curve of space-time. A galaxy remains whole because every star agrees to fall forever. Yet gravity is not the only influence. Something else acts on the universe. Something that competes with gravity at the largest scales. Galaxies gather into clusters, and clusters gather into larger formations. But beyond a certain size, something pushes against this gathering. The expansion of space accelerates. The farther two galaxies are, the faster they move apart. Gravity builds, something else pulls away. Galaxies hold themselves together through dark matter and motion, yet the space between galaxies stretches. Across great enough distances, the pull of gravity weakens, and another force begins to dominate. That force does not come from matter. It comes from the nature of space itself. It is a pressure that causes the universe to expand faster over time. We call it dark energy. Gravity sculpts the galaxies. Dark matter supports them. Dark energy expands the universe around them. The city of stars continues spinning. The arms ripple, the center deepens, and through it all, gravity stays silent. It does not command, it does not compel, it shapes. A single galaxy contains billions of stars. The universe contains billions of galaxies. The mind bends trying to imagine such a number. Yet even this unimaginable vastness obeys the same quiet rule. Mass curves space-time. Curvature guides motion. Motion reveals structure. The cosmos is not chaos. It is architecture. Gravity is the architect. The next chapter follows gravity into the invisible, where dark matter shapes not only galaxies, but the entire skeleton of the universe. Space looks empty to our eyes, yet emptiness is an illusion. Between galaxies, between stars, even between atoms, something silent exerts influence. It does not shine. It does not reflect light. It does not collide with ordinary matter. It leaves no mark that telescopes can photograph, yet it sculpts the universe on every scale. Dark matter. We did not discover it by seeing it. We discovered it by noticing what should not happen. When astronomers measured how fast stars orbit in the outer regions of galaxies, they expected to see a simple pattern. Stars near the center should move quickly. Stars farther away should move slowly. This expectation comes from the same principle that explains why the inner planets of our solar system travel faster than the outer ones. But galaxies do not follow that rule. The stars at the edges move just as fast as the stars near the center. This motion defies what ordinary matter can produce. The mass that we see in stars and gas is simply not enough to create this motion. Something unseen adds gravity. Imagine holding a spinning wheel. If it spins faster than it should, you know there must be extra weight hidden inside the rim. Dark matter is that hidden weight. The stars in a galaxy behave as though they are held inside a massive invisible sphere. They follow paths that agree perfectly with gravity, yet the source of that gravity is nowhere to be seen. The invisible sphere is the dark matter halo. We do not know what dark matter is made of. It is not a form of regular matter that simply does not shine. It cannot be atoms, because atoms interact with light. Dark matter passes through planets and stars as though they are not there. It does not stop. It does not scatter. The only language dark matter speaks is gravity. It adds mass. The universe shapes itself around that mass. Picture a city built around a frame of steel and concrete. The beams are hidden inside the walls. The bricks and windows are visible, but the strength that holds the building upright lies in the skeleton beneath. Dark matter is the skeleton of the universe. Galaxies are the bricks. In the early universe, soon after the first light appeared, matter began to gather. Ordinary atoms were too warm and scattered too quickly to form structures. But dark matter did not interact with radiation. It cooled faster. It condensed sooner. It formed the first clumps. These clumps drew ordinary matter into their gravity wells. The earliest stars formed where dark matter concentrated. Dark matter is not decoration. It is the reason structure exists. If dark matter did not exist, galaxies would not form. Stars would not cluster. Planets would drift without purpose in a smooth, expanding cloud of gas. No patterns, no clusters, no worlds, no us. We owe our existence to something we cannot see. Even now, dark matter shapes the motion of galaxies. It bends the space around them, guiding their paths through the universe. When two clusters of galaxies collide, dark matter passes through without slowing, because it does not interact with ordinary matter. Astronomers detected this behavior when two enormous clusters collided. The gas clouds between them smashed together and heated up, glowing in visible wavelengths. But the dark matter moved straight through, leaving the ordinary matter behind. We saw the gas in one place and the gravity in another. That separation revealed the invisible. The universe left fingerprints. Dark matter forms filaments. These filaments stretch across distances so large that the numbers barely fit into language. Think of threads of gravity forming highways. Along those highways, galaxies gather. At intersections, clusters form. The filaments are not carved by light. They are carved by gravity from invisible mass. When scientists simulate the universe on supercomputers using only gravity and dark matter, the result looks exactly like what we observe through telescopes. The same patterns appear, the same structures emerge, the same skeleton forms. Dark matter behaves simply. It falls toward gravity. It forms halos. It pulls ordinary matter into its wells. It does not resist. It does not radiate away energy. It only gathers. And by gathering, it enables complexity. Somewhere inside that complexity, stars formed. Around certain stars, planets formed. On one of those planets, chemistry became biology. And that biology began to wonder where it came from. Our curiosity is a consequence of dark matter. The universe is not held together by light. It is held together by gravity acting on the unseen. Dark matter defines where galaxies may exist. Where there is no dark matter, nothing forms. No stars, no worlds, no story to tell. We are shaped by the invisible. The deeper we study dark matter, the more it refuses to reveal itself. Detectors buried beneath mountains listen for the faintest collisions, hoping a particle of dark matter will strike an atom and leave a trace. Years pass. Instruments wait in silence. Nothing announces itself. Perhaps dark matter does not collide with atoms at all. Perhaps it only bends space-time. If so, we might never touch it, never trap it, never hold a sample in our hands. Yet we know it exists because the universe moves in obedience to its gravity. Dark matter shapes the motion of stars. It shapes the rotation of galaxies. It shapes the flow of clusters. It shapes the very map of the universe. It is a silent sculptor that never touches its clay. If ordinary matter is the paint upon the canvas, then dark matter is the canvas itself. From the outside, a galaxy appears calm, but step into the mind of gravity and you would feel constant pull. Stars drift within the dark halo. They never escape because the halo extends far beyond the visible starlight. A star near the edge of the galaxy moves with surprising speed. it is held not by the mass of the visible disk, but by the vast, unseen weight surrounding it. If that invisible halo vanished, the galaxy would spin apart like sparks thrown from a wheel. The universe gives us questions that resist simple answers. Why does dark matter exist at all? Why does it not form atoms? Why does it not collapse into stars? Perhaps the answer lies in the earliest whisper of time, when the universe was hot and dense. As it expanded and cooled, matter separated into different kinds. Ordinary matter felt pressure from radiation and was slowed. Dark matter did not interact with radiation. It flowed inward, shaping the first gravitational wells. Across billions of years, those wells deepened. Ordinary matter condensed in their centers and ignited into stars. The stars died and returned heavier elements to space. New stars formed, planets formed, life formed. Every moment depended on structure born from mass we cannot see. We sometimes imagine that humans are small and unimportant because space is vast. Yet the laws of that vastness are written into the atoms of our bones. We are not outside the universe looking in. We are part of its structure. We exist because gravity shaped dark matter halos, which shaped galaxies, which shaped stars, which shaped elements, which shaped life. We are the consequence of darkness. Dark matter does not speak, yet gravity lets us hear its presence. A beam of light passing near a galaxy bends along the curves of space-time. The light acts as a probe, revealing the invisible. Astronomers call this effect gravitational lensing. Where dark matter gathers, light shifts. Sometimes we see a distant galaxy stretched into arcs or rings. The ring is not the galaxy itself, but the image of it, distorted by the halo of dark matter surrounding the nearer galaxy. The lens is invisible, yet its signature is unmistakable. Space is not empty, it is warped. When we look at maps made not from starlight, but from gravitational lensing, we see the scaffolding. Filaments of mass weave through the cosmos. Galaxies do not sit randomly. They cling to those filaments like dew along a spider web. The web stretches across distances, measured not in kilometers, but in millions of trillions of kilometers. Along the strands of that web flows the history of the universe. Dark matter does not fight gravity. It is gravity. A strange thought emerges. We do not see reality directly. We see the luminous tip of something much larger. The stars are only the lanterns hung along the beams. The beams themselves remain unseen, yet without them the lanterns would scatter into darkness. Everything we know rests upon the invisible. There is humility in this realization. We often imagine we understand more than we do. Yet, even now, with all our instruments, with all our equations, with all our theories, we do not know what dark matter is. We know only how it behaves. It does not reveal its nature easily. Perhaps the universe prefers to leave some mysteries in shadow. Still, gravity continues its patient work. Dark matter gathers. Ordinary matter follows. Stars ignite. Galaxies form. Their light crosses unimaginable distances and touches our eyes as faint points in the night. We see only the surface. Beneath that surface lies the scaffold that shaped it. Without dark matter, there would be nothing to hold galaxies together. Without galaxies, no stars. Without stars, no planets. Without planets, no chemistry. Without chemistry, no life. Every moment of human existence depends on this silent architecture. We are not separate from the structure that holds the universe. We are expressions of it. The iron in our blood was forged in a star. The star formed inside a galaxy. The galaxy formed within a dark matter halo. And the halo formed because gravity gathered the unseen. We live inside a story the universe wrote long before we arrived. A story in which the invisible guides the visible. a story in which gravity shapes all things, a story that continues beyond galaxies to the largest scale of all. Dark matter holds the universe together, but something else tries to pull it apart. In the next chapter, the silent architect meets its only rival. The expansion of space-time accelerates, gravity pulls together, dark energy pushes apart. The universe becomes a tug-of-war between creation and expansion. Gravity gathers, gravity shapes, gravity holds. For billions of years, that single influence seemed sufficient to explain everything the universe became. From the collapse of clouds that ignited into stars, to the gathering of stars into spirals of light, gravity guided all motion. Its pull unified the cosmos into structures. Its patience forged worlds. Then something unexpected happened. Astronomers began to measure the distances to faraway galaxies using light that travels across space like a messenger from the past. Certain dying stars, called standard candles, release a predictable brightness. If they appear faint, they must be far. If they appear bright, they must be close. By comparing brightness to distance, astronomers could track how galaxies move over time. They expected to find that galaxies were slowing down. If gravity pulls everything together, then the expansion of the universe should weaken. Galaxies should drift apart more slowly as their gravity interacts. The universe should be decelerating. It was not. The galaxies were not slowing. They were moving apart faster than before, not just drifting, accelerating. The expansion was speeding up. Space itself was stretching more rapidly with every passing moment. Something was pushing. This discovery overturned everything. Gravity, the architect of matter, seemed to be losing a battle against something that did not behave like matter at all. Whatever force was driving galaxies apart was not coming from stars or planets or dark matter. It came from space itself. The universe contains a pressure that pushes outward. Scientists called this presence dark energy. Dark energy is not energy in the way we understand energy. It is not stored inside objects. It does not flow. It does not radiate. It does not collide. It does not gather. It simply exists as a property of the fabric of space. As space expands, there is more of it. More expansion means more space. More space means more dark energy. More dark energy means stronger expansion. The universe accelerates itself. Imagine drawing dots on the surface of a balloon. The balloon represents space. The dots represent galaxies. As the balloon inflates, the dots move apart, even though they do not travel across the surface. The space between them grows. Now imagine that as the balloon grows, it pushes itself to expand faster. That is the universe. Gravity pulls matter inward. Dark energy pushes space outward. On small scales, gravity dominates. It holds planets around stars. It binds stars into galaxies. It even gathers galaxies into clusters. But across extremely large distances, the outward pressure of dark energy overwhelms the pull of gravity. Every second, the universe becomes larger. Every moment, the distant galaxies drift farther away. Every year, the rate of separation increases. What begins as a gentle push becomes a determined pull. Faraway galaxies disappear from view. Their light stretches into longer wavelengths until it becomes invisible. The cosmos fades at the edges. The night sky grows quieter. The struggle between gravity and dark energy defines the future. Gravity tries to gather. Dark energy tries to separate. For a long time, astronomers wondered if the universe would eventually slow, stop, and collapse. They called it the Big Crunch, a time when gravity would win and pull everything back together. But dark energy changed the ending. The collapse will never come. The expansion will not stop. Over unimaginable stretches of time, Every distant cluster of galaxies will slip beyond the horizon of what can be seen, not because they move too fast, but because the space between becomes too large. Their light will never reach us. They will vanish not through destruction, but through distance. Dark energy is indifferent to our sense of scale. It does not know it is changing everything. We live in a brief moment when the universe remains visible. We can still see the filaments of dark matter. We can still observe distant galaxies. We can still measure the expansion. Future observers, billions of years from now, will not be able to see what we see. The galaxies will be gone. The evidence of the beginning will fade. The universe will appear empty and eternal. We live in a cosmic window where the truth is still visible. Dark energy does not erase structure. It limits where structure can form. Gravity still rules within galaxies and within clusters. Stars continue to burn. Planets continue to orbit. Black holes continue to shape space-time. But beyond that scale, the universe drifts apart. Gravity holds the local. Dark energy commands the vast. It is as though the cosmos is divided into two realms. One governed by the sculptor that gathers matter. The other driven by the influence that stretches space-time. For the first time since the beginning, gravity meets an equal and opposite contender. Dark energy does not feel like a force in the way gravity does. Gravity announces itself through weight and motion. Dark energy does not pull or push against bodies. Instead, it changes the stage beneath them. Space stretches. The actors do nothing, yet the distance between them grows. To understand this, imagine two ships drifting silently on a perfectly calm ocean. Neither uses its engines. Neither changes direction. Yet somehow the ocean itself stretches. The ships separate. They do not feel motion. They do not see current. But the horizon between them expands. That is the universe. The galaxies are the ships. Dark energy is the stretching of the ocean beneath. At its core, this reveals something remarkable. Space is not merely the emptiness where things exist. Space has properties. It can bend under mass. It can ripple when massive bodies merge. It can stretch under its own pressure. Einstein predicted that empty space might contain something that resists compression. He introduced a constant that allowed space to push outward. He later removed it, believing it unnecessary. The expansion of the universe proved that his idea had been right all along. The battle between gravity and dark energy is not dramatic. There is no sound, no collision, no boundary. The influence of one fades as the other grows. Gravity becomes irrelevant once distances grow too vast for matter to interact. Dark energy becomes dominant simply because space keeps creating more of itself. The future becomes slow and quiet. Stars will continue their long burning lives. New generations of stars will ignite from clouds of gas. Over time, fewer clouds will remain. Galaxies will age. The brightest blue stars will fade first. The yellow suns will burn for billions more years, then transform into white embers. Smaller red stars will glow long after everything else cools. Their light will last for incredible stretches of time. Each star carries out its life cycle, unaffected by the accelerating expansion. But even stars cannot fight the loss of raw material forever. When galaxies exhaust their supply of gas, no new stars can form. Gravity will continue to hold the remaining stars in their orbits, but the galaxy will dim. Dark energy will continue to stretch the fabric around it. Clusters of galaxies will remain held together by gravity. Their dark matter halos will still bind them, but beyond the borders of each cluster, expansion wins. The distances between clusters will increase until the light from each neighboring cluster can no longer reach the others. Space will grow so quickly that the light cannot cross the gap. The universe will separate into island clusters, surrounded by an expanding sea of nothing. Trillions of years later, each surviving cluster will become a lonely city of fading stars. Go farther into the future and even that will change. The stars will cool into black remnants. White dwarfs will fade to darkness. Neutron stars will chill. Black holes will consume what falls too near. Time will stretch onward. Dark energy will continue to widen the spaces between these remaining objects. Black holes will evaporate through slow and steady quantum release, a whisper that takes unimaginable lengths of time. In that distant future, gravity will not lose because it weakens. It will lose because space becomes too vast for gravity to gather anything new. Gravity will still curve space-time, still command the paths of matter, still bind whatever remains. But on the scale of the universe, dark energy will hold the final word. There is a quiet sadness in imagining such an ending, a universe that thins and fades, a cosmos that forgets its own beginning. But this sadness belongs only to imagination. The universe is not tragic. It does not cling. It becomes what its laws demand. It transforms, it moves, it evolves. We are living in the only era where the story is visible, where distant galaxies fill the sky, where the filament web of dark matter can be traced through the positions of clusters, where light from the beginning of time still reaches us as a faint afterglow. We are here at the moment when both gravity and dark energy are visible to our senses. Had we existed in the distant past, the universe would seem smaller and more crowded. The acceleration would not yet be obvious. Had we existed in the distant future, other galaxies would be gone from view. The cosmic web would fade. We would look into the dark and believe our cluster was the whole of existence. We would never know the truth. In this small and temporary window, we see the universe as it truly is. A place where gravity builds structure and dark energy loosens it. A place where creation and dispersal coexist. A place where light travels across space that expands beneath it. Nothing in nature is wasted. Gravity gathers. Dark energy opens. Between these two influences, stars ignite, planets form, and life wakes. We exist between forces, and the universe continues to expand. The next chapter follows gravity as it draws all of this structure into a vast interconnected network. The cosmic web, the largest pattern the universe has ever made. When we imagine the universe, we often picture scattered dots of starlight. A lonely star here, a distant galaxy there, empty space between them that stretches on forever. But emptiness is a misunderstanding. The farther we look, the more the illusion dissolves. With enough distance, the scattered points reveal a pattern. Galaxies gather in filaments. Filaments cross and branch and connect into vast structures like rivers flowing through a continent of space. Here and there, these rivers meet and form immense junctions of matter, superclusters, cosmic cities. Gravity did this, not by force, but by patience. After the beginning of the universe, space expanded rapidly. Hydrogen and helium filled the darkness in a near-perfect fog, almost smooth, almost uniform, but not perfectly. In some places, the fog was a fraction denser than in others. A few extra atoms here, a slight absence there. Gravity noticed the differences. That faint unevenness became destiny. Where matter was denser, gravity pulled harder. The region grew heavier. It attracted more matter. It deepened. A tiny puff of gas became a seed. In places where matter was thin, gravity had nothing to work with. Those regions became cosmic voids, empty expanses between the filaments. Dark matter guided the process. It gathered into long, invisible strands. Ordinary matter flowed along these strands like water along a channel. The strands thickened. Pockets formed. In the pockets, matter collapsed into the first galaxies. Between them stretched the silent threads of dark matter. If we could see the universe without stars or planets or gas, and leave only gravity itself, we would see a spider web made of pure structure. A network of threads and nodes stretching across billions of trillions of kilometers. The pattern is not random. It follows the mathematics of growth. Small clumps attract more material and grow into larger structures. The rich become richer. Gravity amplifies unevenness until structure forms. Galaxies do not float alone through space. They flow along these filaments. They move toward the intersections where gravitational valleys lie. Every filament is a highway. Every intersection is a gathering place. The galaxies that follow these paths do not know they are following anything at all. They are simply falling along the direction of steepest curvature in space-time. Gravity draws them. Dark matter guides them. We exist inside this web. Our Milky Way lives within a filament of the cosmic network. It orbits near the center of a local cluster called the local group. This cluster is one tiny knot within a much larger structure named Laniakea. In the language of Earth, the name means immense heaven. It stretches across hundreds of millions of light years. Every galaxy inside it flows along currents of space-time toward a single gravitational basin. It is not a place, it is a direction, a flow, a collective motion. You are falling with the galaxies, and you do not feel it. The Earth orbits the Sun moves around the Milky Way. The Milky Way drifts along a filament. Everything flows. The cosmic web changes our sense of scale. A solar system is not large. A galaxy is not large. Even a cluster of galaxies is only one node in the web. The web spans the visible universe. It is the largest structure gravity has ever created. A map of the universe is not a picture of chaos. It is a blueprint. The cosmic web proves something profound. Structure is not rare. Structure is inevitable. Gravity takes what begins as disorder and shapes it. It does not require design. It does not require intention. The laws of nature are enough. And yet, hidden inside that structure are moments of astonishing delicacy. In the heart of a filament, a cloud collapses. A star ignites. Around that star, planets form. On one of those planets, chemistry begins to copy itself. Life emerges. Consciousness awakens. A mind looks outward and wonders where it came from. We are the web becoming aware of its own architecture. From a distance, the web appears eternal. But even this vast structure faces change. Dark energy pulls the threads apart. The filaments stretch as space expands faster. In the distant future, the web will thin and its connections will fade. But the pattern will not vanish. The galaxies within each filament will remain bound to their local gravity wells. The web will loosen, but never fully erase the memory of its formation. Gravity does not build in haste. It builds in time. The cosmic web is a frozen echo of the earliest heartbeat of the universe. It shows us that even from the faintest unevenness, structure emerges, matter organizes, light forms, life eventually appears. We are pieces of that pattern. The cosmic web is not only a structure, it is a history written in distance and motion. Every filament remembers where matter gathered. Every void remembers where matter did not. If we could rewind time and watch the web collapse backward, the filaments would thin, the clusters would dissolve, and the galaxies would drift apart. Eventually, the strands would fade into a uniform fog. Even earlier, before stars or planets or nuclei were stable, before light had separated from matter, the universe would be a hot, indistinct ocean of energy. No structure, no pattern, no directions, no web. Gravity wrote the first chapter, the moment unevenness appeared. That unevenness emerged from quantum fluctuations in the earliest instant of existence. Microscopic variations in density were stretched by expansion into macroscopic differences. Gravity found those differences and made them permanent. Each fluctuation became a seed. Each seed became a filament. Over billions of years, the seeds grew into the largest structure the universe has ever produced. And we, fragile and brief as sparks, were born on one tiny world inside this web. We humans are used to thinking that we are spectators. We imagine ourselves standing outside the universe, observing it from a distance. But we are not outside it at all. We are inside the pattern. Our world orbits a star. Our star drifts along a spiral arm. The Milky Way follows a filament. The filament flows toward a gravitational basin. We are fully embedded within gravity's design. Everything you have ever known is part of a motion that began before atoms existed. The cosmic web teaches something profound. Structure comes from simplicity. Gravity acts on tiny differences until complexity emerges. The web is the direct consequence of the nature of space-time and mass. No designer required, no blueprints drawn, just laws acting on conditions. Dark matter forms the bones of the web. Gravity tightens the strands. Galaxies light the intersections. We see the glow, not the scaffold. We see stars in the thousands and think that is everything. Yet what we see is only the luminous skin over an invisible architecture. A beam of light from a distant galaxy may pass near dark matter and bend. The light reveals the curve. It draws a map upon our instruments. We trace that map and find the threads. Observations from powerful telescopes have captured entire networks of galaxies. In the images, they resemble neurons in a brain. Filaments connect and diverge. Clusters gleam like nodal points. The similarity is not metaphorical. Both are networks built by connection and growth. Both arise because simple rules, repeated over time, produce intricate patterns. In a brain, neurons fire and learn. In a universe, gravity gathers and shapes. The cosmic web is not only grand in scale, it is patient beyond imagining. Structures form over billions of years. Time is not an obstacle. Time is the raw material gravity uses to carve. Stand beneath the night sky on a quiet night. Look up. Every star you see belongs to the Milky Way. You cannot see the filaments from here. They lie far beyond the reach of naked sight. But they are there, tensioned across darkness, like strings of a hidden instrument. The stars we see are notes. Gravity is the hand that tuned the strings. Even voids have meaning. They are not failures of structure. They are part of the design. Without emptiness, there is no web. Without absence, there is no presence. The universe requires contrast. Gravity gathers only where matter exists. The places without matter define where matter may go. We exist within this contrast. Our future is shaped by this network. Gravity continues to guide galaxies along the strands. But dark energy stretches the space around the strands. Over trillions of years, the filaments will lengthen. The nodes will pull tighter. The web will continue expanding, but the connections between distant nodes will weaken. In the far future, only local clusters will remain bound. The rest of the web will slip beyond the cosmic horizon. Galaxies that are now visible will vanish one by one as distance outruns light. The universe will grow emptier to the eye. Even as structure remains in isolated pockets, the web will not die. It will become memory. A memory of the moment the universe chose organization over chaos. This web is the reason anything exists in a form we can recognize. It gave birth to galaxies. Those galaxies gave birth to stars. The stars forged the atoms that built worlds. The worlds produced life. The life evolved minds that could observe and understand. And those minds now contemplate the web that produced them. We are the web looking back on itself. Gravity not only builds the cosmos, it builds the observers of the cosmos. The next chapter will follow gravity to its final extremes, to the places where time slows, to the stars that die, to the black holes where space-time curves so sharply that existence folds. Gravity shapes structure. Gravity shapes motion. Gravity shapes time. Time is the next frontier. Time feels constant to us because our lives unfold on a planet where gravity remains steady. Clocks tick in predictable rhythm. Minutes follow one another in familiar pace. Yet this consistency is not universal. Time is not an independent stage where events occur. Time is shaped by gravity. It stretches or compresses depending on how strongly space-time curves. Near massive objects such as stars or planets, time moves more slowly. Far from mass, time flows more freely. We do not notice this on Earth because the difference from one place to another is small, but when gravity becomes strong, the effect becomes unmistakable. Einstein revealed that gravity is not a force pulling downward. Gravity alters the geometry of space and the rate at which time passes. A clock on the ground floor of a building runs slightly slower than a clock on the top floor. The difference is tiny, but measurable. Satellites that orbit Earth must compensate for this effect. Their clocks tick faster than clocks on the surface because they orbit farther from the curvature that Earth creates. Without correcting for this difference, our global navigation systems would drift and become useless within a few minutes. Time is not separate from gravity. Time responds to it. The deeper something sits inside a gravitational well, the slower time passes for that object. A person living near a massive star would age more slowly relative to someone far away. They would not feel it. They would not notice the change. Time would feel completely normal to them. But compared to the rest of the universe, their moments would stretch. The universe would age more quickly, while their own time ran gently. This slowing of time becomes dramatic when stars begin to die. A star spends most of its life balancing two influences. Gravity attempts to crush the star inward, while nuclear fusion pushes outward. As long as the outward push and the inward pull remain equal, the star shines steadily. When fusion stops, gravity finally gains control and collapse begins. Stars like our Sun swell into enormous red giants and then shed their outer layers, leaving behind a dense core. That core becomes a white dwarf. It is small, roughly the size of Earth, yet it contains a mass comparable to the Sun. A teaspoon of white dwarf material would weigh as much as a mountain. It does not collapse further because the electrons within resist being squeezed closer together. Time near a white dwarf flows more slowly than time far from it. The gravitational curvature is stronger, and the flow of moments shifts accordingly. More massive stars do not stop at that stage. Their collapse continues until electrons and protons combine into neutrons. The result is a neutron star. Neutron stars are far smaller than white dwarfs and much denser. A spoonful of neutron star material would weigh as much as an entire mountain range. Their gravity is intense enough to bend the paths of nearby photons. Time slows dramatically in their presence. Space curves so sharply that orbits near them shift from circles to stretched ellipses. The star rotates so rapidly that beams of radiation sweep across space like lighthouses. We see these flashes and call them pulsars. These objects show that gravity does not merely shape motion, it shapes the passage of time. As gravity strengthens, time slows. If gravity becomes extreme enough, time nearly stops. The most extreme example occurs when a massive star collapses past the neutron stage. Gravity overwhelms all resistance. Nothing can counteract the compression. The collapse continues until the star becomes a black hole. A black hole curves space-time so sharply that the inward path becomes unavoidable. The event horizon marks the boundary. Once anything crosses that threshold, it cannot return. Not because a force holds it down, but because all paths through space-time lead inward. time near the event horizon behaves differently. To someone watching from afar, an object falling toward the horizon appears to slow. It moves more slowly with each passing moment. The light from that object becomes redder until it fades entirely. From the perspective of a distant observer, the object never crosses the horizon. It appears to freeze in place just outside the boundary. But to the falling object, time continues normally. It crosses the threshold without hesitation, unaware that the rest of the universe now sees it locked outside the final moment. Gravity separates experiences. Time becomes personal. Inside the event horizon, the curvature becomes absolute. All directions lead to the center. There is no path that escapes. The idea of time loses its usual meaning because the geometry no longer allows a future that returns to the outside universe. Black holes are not holes. They are destinations within space-time. They store mass and alter the shape of time around them. Black holes also grow. When matter falls inward, the mass of the black hole increases. The event horizon expands. At the center lies a place where our understanding of physics breaks. We call it the singularity, not because we know what it is, but because our equations cannot describe it. Space and time curve infinitely. Time ends not in distance, but in geometry. Yet black holes do not last forever. Over incomprehensible stretches of time, they release energy in a faint glow. This release is slow. A large black hole would take far longer than the current age of the universe to evaporate. Eventually, nothing remains. Even the most powerful expressions of gravity fade. The universe moves on. We often think of time as a straight path leading from past to future. Gravity reveals that time bends, it stretches, it slows. Time is part of space-time, and space-time responds to mass and motion. Every orbit is an arc through time as much as through space. Every star bends time as well as light. Every galaxy distorts the clocks within it. Time is not universal. It is local and elastic. As stars burn their fuel and collapse into remnants, gravity continues to reorganize matter. Planets drift. Moons fall inward or spiral outward. Orbits adjust. Over long periods, stars in galaxies exchange momentum and energy. Some are ejected into intergalactic space. Others migrate inward toward the core. The galaxy ages not in years, but in cycles of motion. Gravity continues shaping time long after stars have faded. Trillions of years into the future, the universe will be quiet. Star formation will slow. Most stars will cool into dark remnants. The galaxies will become collections of embers, slowly drifting along the filaments of the cosmic web, until even motion loses meaning. Black holes will swallow what remains until they too evaporate. Time will stretch, thin, and eventually hold no events to mark its passage. All of this happens because gravity curves space-time. And space-time defines time itself. Over immense spans of time, the universe becomes a place where motion slows and change becomes rare. Stars that once blazed with intensity cool into black remnants. Planets that once circled them are either swallowed by expanding stars during their red giant phase or drift aimlessly in the darkness after their star fades. Gravity continues to work, but with fewer objects that can respond. A planet without a star still moves, but without light, there is no warmth. The chemistry that once produced life falls quiet. Even in silence, gravity still sculpts. Objects without nearby influences gradually lose energy through tiny interactions and settle into long, stable orbits, or drift into the emptiness between stars. Galaxies age as well. Over time, stars transfer energy and momentum to one another through their gravitational interactions. Most of these exchanges are tiny, but they accumulate. Some stars are slowly flung outward into space. Others sink inward toward the center of the galaxy, where a supermassive black hole waits. The process is slow, lasting trillions of years, yet gravity never becomes impatient. It works with whatever exists and whatever time permits. The galaxy becomes less structured, its stars dim. The grand spiral arms that once lit the sky no longer regenerate. The ability to form new stars fades as the gas supply is exhausted. What remains is a collection of fading stars orbiting a massive core. Eventually, even those stars will be gone. The white dwarfs will cool into dark spheres. Neutron stars will fade as their magnetic fields weaken. Black holes will dominate the structure for an age beyond anything we can meaningfully imagine. Time near a black hole moves at a slower pace than time far from it. This means that black holes are not only massive, they are time machines of a kind. They create pockets of slow time that continue to exist even when the rest of the universe moves faster. An object falling toward a black hole does not sense anything unusual until the final moments. Gravity alters the external perception, but not the internal one. Time remains normal to anyone within their own gravitational environment, even when the rest of the universe ages without them. In the distant future, black holes will be the last places where gravity still shapes time in a noticeable way. Space around them will continue to stretch. Dark energy will accelerate the expansion. The distance between surviving structures will grow so rapidly that no signal can cross the gap. Galaxies will become isolated islands. Within those islands, black holes will slowly evaporate as they radiate energy. As they lose mass, their event horizons shrink. When the black hole becomes small enough, the radiation accelerates until it releases its mass in a final burst. Then, the last great curvature of space-time disappears. Once the black holes are gone, gravity no longer influences structure in a familiar way. Matter is then reduced to scattered particles drifting through a vast emptiness. Without mass concentrated into stars or galaxies, gravity no longer shapes time. Space is cold. Time is long and mostly uneventful. The universe once filled with light becomes a place where events are rare. Each moment stretches because there is nothing left to measure it. Time becomes not a sequence of changes, but an open expanse. This scenario is not tragic. It is simply the outcome of the laws that allowed stars and planets and life to exist. The same gravity that once gathered matter to ignite stars eventually becomes the force that lets their remnants fade. The cosmos evolves from intense interaction into a final calm. The silence of the far future is part of the same story that includes the birth of galaxies and the forming of worlds. The astonishing truth is that gravity not only shaped space and matter, it shaped time itself. Without gravity, time would flow uniformly everywhere. There would be no difference between here and there. But gravity gives time texture. The deeper the gravitational well, the slower time moves. A clock near the surface of a planet ticks more slowly than one far away. This effect has been tested countless times. At the level of everyday experience, we do not feel it, but the universe does. Every second your body ages differently than a satellite above you. Every moment time flows differently near massive mountains, deep valleys, or distant planets. Time is relative not as a metaphor, but as a physical fact. We are not separate from space-time. We exist inside it. We feel its rules. We move along its curves without choice. The connection between gravity and time means that our lives are woven into the structure of the cosmos. The seasons of our planet exist because Earth orbits the Sun and rotates. The orbit exists because gravity curves space-time. The rotation exists because of the angular momentum inherited from the cloud that formed the solar system. Time for us is shaped by these motions. Each day, each year, Each lifetime is measured by movement through curved space-time. Even consciousness depends on time. Without the sequence of moments, thought could not unfold. Memory requires time. Awareness requires time. Life requires time. And gravity shapes time from the moment the universe begins until the moment it grows cold and still. We live in a brief, bright moment when stars still shine and time still feels familiar. We are the universe becoming aware of its own geometry. Our lives are short, but they are suspended within a cosmic structure that spans everything from atoms to superclusters. Time flows through us. Gravity gives that flow shape. Space-time is the stage. Gravity is the sculptor. The next chapter will gather everything. Gravity holding matter. Dark matter supporting structure. Dark energy shaping fate. The universe holds together because gravity cares for the possibility of structure. Gravity is the quiet thread that weaves structure from chaos. It is not loud or sudden. It does not shout or command. It works through patient accumulation, through the slow shaping of paths and the bending of time. When we look back across the chapters of cosmic history, we see the same principle at every scale. A cloud of gas collapses into a star because gravity gathers. A star shines because gravity allows fusion to balance its inward pull. Planets orbit because motion finds balance with gravity. Galaxies rotate and hold their shape because gravity and dark matter form an invisible architecture. The cosmic web stretches across the universe because gravity magnifies the slightest unevenness and turns it into structure. Even the flow of time responds to gravity. Every chapter has been gravity revealing something new. When we think of the universe falling apart, we imagine stars drifting away, or planets breaking loose, or galaxies tearing into fragments. Yet the universe does not fail into disorder. Order emerges through natural laws. Gravity creates environments where complexity becomes possible. The earliest atoms that formed after the beginning of time existed in a simple state: hydrogen, helium. They drifted through the expanding universe with little structure. If the universe had remained uniform, nothing more interesting would ever have occurred. The laws of nature would have remained silent. No stars, no planets, no chemistry, no observers. But the young universe contained tiny differences in density. These differences were extremely small, but gravity noticed them. Where there was slightly more matter, gravity pulled harder. The region thickened. Over unimaginable spans of time, those small variations deepened into wells where gas collected. The first stars formed. The first galaxies took shape. Gravity is not a force of destruction. It is a force of potential. In the interior of stars, fusion created heavier elements: carbon, oxygen, nitrogen, elements that allow chemistry to become complex. When massive stars reached the end of their lives, they exploded and scattered those elements through space. Gravity gathered them again, and new stars formed. Around some of those stars, planets emerged. On some of those planets, chemistry combined into molecules that copied themselves. On at least one world, those molecules became life. None of this required planning. None of this required direction. It required only the laws of physics and enough time. Gravity gave the universe time. The existence of dark matter changed the scale of structure. Its invisible mass formed halos around forming galaxies and deepened the gravity wells that ordinary matter fell into. Without dark matter, the galaxies we see could not have remained whole. Their rotation would fling stars into the dark. Yet dark matter acts only through gravity. It neither glows nor collides nor reacts. It simply gathers and shapes. Gravity does the rest. We see only the illuminated tips of structures that dark matter supports. Then, dark energy entered the story. The universe began to expand faster. Galaxies drift farther apart as space stretches. Gravity still binds stars into galaxies and galaxies into clusters, but dark energy ensures the universe will grow emptier over time. On small and medium scales, gravity remains the dominant influence. On the scale of the universe, dark energy moves everything apart. The tension between gravity and dark energy determines the future. Gravity builds structure. Dark energy takes it away from the reach of other structures. Gravity is the sculptor. Dark energy is the emptiness that widens around the sculpture. And yet, even in this widening universe, gravity never loses its meaning. Wherever matter gathers, gravity creates shape. Dark energy spreads space, but gravity enriches it. Planets will continue to orbit stars for billions of years. New stars may still form in the remaining gas clouds of galaxies. Gravity preserves whatever remains long after the distant parts of the universe fade beyond the cosmic horizon. We look at our own world and see trees, mountains, clouds, oceans. We feel soil beneath our feet and wind on our skin. We do not feel the curve of space-time beneath us, yet every moment of our lives depends on it. The ground we walk on exists because Earth gathered from a disk of material. The disk formed because gravity shaped the orbiting gas. The gas came from the remnants of earlier stars. Those stars ignited because gravity compressed hydrogen into fusion. The atoms inside our bodies were once inside a star. Without gravity, those atoms would still be scattered as gas. We are the consequence of matter choosing to gather. Every step you take is supported by the result of 4.5 billion years of gravitational evolution. The orbit of Earth creates the year. The rotation creates the cycle of night and day. Seasons exist because Earth is tilted on its axis, and that tilt persists because gravity stabilizes the rotation. Time itself has meaning to us because gravity created cycles. Without gravity, there is no rhythm. Without rhythm, there is no sense of time. The more carefully we study gravity, the more it feels like an agreement between matter and motion. Gravity does not force matter along a path. It shapes the space around matter, and matter chooses the path that feels straight. A planet orbits a star, not because the star pulls it inward, but because space-time curves. The planet follows the shape of that curvature. Every orbit is a conversation between motion and geometry. The planet is not trapped. It is free to follow the most natural path available to it. This reveals something subtle. Gravity does not hold the universe together by clinging to it. Gravity holds the universe together by giving it the possibility of structure. When matter gathers, it has somewhere to go. When it moves, it has a path to follow. Gravity creates choices. Without it, space would offer no guidance at all. Time itself emerges from gravity's influence on motion. A clock on Earth ticks differently than a clock above Earth because the flow of moments depends on curvature. The faster we move or the closer we are to mass, the slower time becomes. Gravity shapes not only the world, but the experience of the world. In the distant future, when stars fade and galaxies drift apart, gravity will continue, shaping whatever remains. Black holes will persist the longest. Time around them will move slowly. They will store mass and curve space-time long after ordinary stars are gone. Eventually, they too will evaporate. The universe will grow cold and thin. Every change will take longer. Time will stretch without markers. But gravity will have already done its work. The universe will have lived a life of extraordinary complexity. All because matter bends space and space guides motion. We exist during the brief era when light still crosses the distances between galaxies. We can still look out and see evidence of the beginning of time. We can trace the cosmic web. We can measure the rotation of galaxies and infer the presence of dark matter. We can observe the acceleration of expansion and deduce the influence of dark energy. Future observers will not be able to do any of this. They will see only the local cluster, a lonely island in a wide, silent ocean. They will think that is the entire universe. The evidence of the beginning will have vanished from sight. We live in the only era where the universe reveals itself. Gravity gave us that chance. It gave us structure. It gave us time. It gave us a stable world where life could begin and evolve. It gave us the atoms in our blood. It gave us orbits and seasons. It gave us opportunity. We are not separate from gravity. We are shaped by it. Gravity shaped the world, and then the world shaped us. Our bones formed so that we could stand against the pull of gravity. Our inner ear developed because balance requires awareness of that pull. Even the way we walk is a response to the constant downward influence on our bodies. Life adapted around gravity because gravity is the first environment every planet provides. Remove gravity, and everything that life has learned becomes useless. Muscles weaken, bones lose density, blood circulates differently. The shape of living beings reflects the shape of the space-time they inhabit. Life does not merely exist in gravity. Life grows into gravity and becomes something that could not exist without it. When we look up into the night sky, we experience gravity from below. We feel its pull holding us to the ground, while we look into a sky that seems weightless. But in truth, everything above us is falling as well. The moon falls around Earth. Earth falls around the sun. The sun falls around the center of the Milky Way. The Milky Way falls along a filament of the cosmic web. Each orbit, each drift, each path is a fall guided by geometry. The universe is not stationary. It is a constant movement of matter finding the straightest path through curved space-time. In the language of Newton, gravity seemed like a force that acted over distance. In the language of Einstein, gravity shapes the rules that motion obeys. And in the language of observation, gravity gives rise to pattern. When we step back far enough, the universe becomes a tapestry. Filaments weave across space, clusters gather where the strands meet, and voids open between them like calm lakes between mountain ranges. The pattern is intricate, yet every part emerged from the same law. Mass bends space-time, and space-time guides motion. A structure, the size of the observable universe, arises from a rule that fits in a single sentence. The simplicity of that rule does not limit its results. It frees them. If we remove gravity from the universe, everything else fails. Without gravity, no stars ever ignite. Gas remains thin and scattered. Hydrogen and helium never compress into fusion. Light never shines. Without stars, heavy elements never form. There are no planets, no oceans, no surfaces, no atmosphere to breathe, no chemistry to combine into living systems. Even atoms would struggle to remain stable because many processes that allow particles to gather depend on gravitational assembly at cosmic scales. The periodic table exists because gravity permitted stars to live long enough to create it. Without gravity, the universe would remain a dark and silent haze. Gravity does not simply hold the universe together. It allows the universe to become interesting. What makes this realization even more remarkable is that gravity is the weakest of the fundamental interactions. The electromagnetic force is immensely stronger. The strong nuclear force binds the nucleus itself and is stronger still. Even the weak force affects atomic behavior more readily than gravity. Yet gravity alone shapes the structure of the universe. It is the weakest force, yet across large scales it becomes the dominant influence because it never cancels. Positive and negative charges neutralize one another. Nuclear forces operate only across tiny distances. Gravity extends everywhere. Every bit of mass contributes. Over great distances, small contributions accumulate and become architecture. Gravity is slow, yet unstoppable. It gathers the smallest grains of dust in orbit around newborn stars. It sculpts those grains into worlds. It arranges worlds into systems. It arranges systems into galaxies. It arranges galaxies into the cosmic web. In every corner of existence, gravity builds from what is available. It takes scattered chaos and convects it into form. It never demands perfection. It demands only time. And time itself bends to accommodate gravity. When gravity is strong, time slows. When gravity weakens, time eases. This means that the past and future are not the same everywhere. A star near a massive black hole ages more slowly than a star in the outskirts of a galaxy. A satellite orbiting Earth experiences a different rate of time than a clock resting on the ground. Our definition of a second depends on our distance from mass. Time is elastic because gravity shapes the stage where moments occur. We measure our lives in decades. Gravity measures its work in billions of years. From our perspective, the universe seems stable. Stars appear fixed in position. The Milky Way seems constant, yet gravity is rearranging everything, just slowly enough that we seldom see it. Solar systems are not frozen configurations. Planetary orbits shift over long spans. Moons migrate outward. Some worlds may eventually be lost to space or collide with one another. Stars move within galaxies like fish within a school, each following the invisible guidance of curvature. Gravity does not contain, it choreographs. When the universe grows old and the stars have finished their fuel, gravity still remains. Black holes will define the shape of space-time long after everything else dims. Even when the last black hole evaporates, gravity will have sculpted the entire history. The future that follows is quiet, perhaps nearly featureless. But the structure of that distant future is built from everything gravity allowed to happen before. We understand gravity not only with mathematics, but with experience. We feel its pull with every step. We measure it in the rhythm of our heartbeat as we climb a hill and work against it. We see evidence of it in the arc of a thrown stone. We know how effortlessly something falls, but we seldom consider that the same law governs the arc of planets and the spin of galaxies. The pebble that falls from a hand follows the same rule that guided the birth of stars 14 billion years ago. When we drop something, we participate in the universal behavior of matter responding to curvature. The universe holds together because gravity allows structure, because dark matter amplifies gravity into large-scale architecture, because dark energy stretches the stage without disturbing the local sculptures gravity creates. The three influences coexist. Gravity shapes, dark matter supports, dark energy expands. One gathers, one stabilizes, one opens space. Together they create possibility. Without gravity, there is no order. Without dark matter, there is no framework. Without dark energy, the universe never learns to change. Life is possible because gravity balanced its need to gather with enough stillness for stability. Too much gravity and stars collapse too quickly. Too little, and stars never ignite. Our sun sits in a balance that allows a steady flow of energy at just the right scale to support the thin film of life on a small planet. And that planet orbits at a distance where water can exist as liquid. In that liquid complex, chemistry emerges. In that chemistry, the ability to remember and respond to surroundings evolves. Across time, memory becomes awareness. Awareness becomes thought. Thought looks outward and wonders. The universe shaped us through gravity. Now we use the minds that gravity allows us to look back into the structure that formed us. When we observe galaxies, we are not just studying distant objects. We are witnessing our own ancestry on a cosmic scale. We are made of matter that gravity gathered from the remains of stars. We are sustained by a star held together by gravity. We live on a world assembled by gravity. We find meaning in time shaped by gravity. And when we look outward and feel wonder, that emotion is possible because gravity made us curious beings in a structured universe instead of isolated particles drifting through nothingness. From the first unevenness in the early universe to the final quiet chill of deep time, gravity is the persistent presence, not controlling, not demanding, simply allowing structure to arise. Gravity cares in the only way the universe can express care, by making room for complexity to appear, endure, and understand. The universe holds together because gravity gives it a chance to become more than scattered dust. It gives it the chance to become stars, planets, oceans, life, and eventually awareness. We are gravity's proof that structure matters.